Welcome back. We're going to look at another accumulation approach here to approximating pi, and this is the Wallace formula, which looks like this. So pi over 2 is equal to 2 over 1 times 2/3 times 4/3 times 4/5 times 6/5 times 6/7 times 8/7, and so on and so forth forever. So first of all, note that this is a product instead of a sum. So we're multiplying between each thing every time. So what does that mean we have to do for the initial value of our accumulator variable? Well, if we had it at 0, like we did for the sum, then we'd always get 0 as a result. So we want 1 because that's the identity in multiplication. Secondly, if we look at these in pairs, note that the numerator stays the same, and those are even numbers starting at 2. 2, 4, 6, 8, and so on. And then the denominators in the pairs here, the left denominator is the numerator minus 1. The right denominator is the numerator plus 1. Okay? So let's take a look at our iterative development of that function using the same sort of idea as we did with the Leibniz function. That is, we're going to develop it in pieces so that we can test it iteratively and make sure that it works in small bits. So I'll call this Wallace, and again it'll take pairs now, similar to the terms function that we had before. I'll set my accumulator to 1 because again it's a multiplicative accumulation rather than an additive one, and so we have to use the multiplication identity. Start out my numerator at 2, and for a pair in range pairs, we'll go ahead and work on building up our product. And after each thing we do know that we'll have to increment our numerator by 2. So that'll be all I do right now, and then I'll just return the accumulator at the moment because that's, again, it's just a temporary placeholder, a stub. So I define that function, then I should be able to call it, and what will I get back? Well, if you said 1, you are correct because we've never changed that product version, or the accumulator variable rather. Okay, now we noticed that we had a left and a right term in each of the pairs. The left term was always the numerator divided by the numerator minus 1, while the right term was always the numerator divided by the numerator plus 1. Okay, and then we can do our accumulation. So our accumulator will be the accumulator current value times the left term times the right term. Okay? And then at the end, we'll return the accumulator. So let's see what we get here with this. Now we're going to get something different. It won't be 1 every time. And if we look at these values, like 1.56, 1.57, 1.57, those look like they are about half of what they should be. And that's correct because if we go back to our formula here, it was this product was pi over 2. So to get pi after the for loop is complete, what I have to do is multiply my accumulator by 2 and make sure that I return that value pi at the end. Okay, so redefine the function, and let's enter these and see what we get. 3.13, 3.14, 3.1415. Great. So there we go. That's the Wallace function. And that is our second accumulator pattern in the approximation of pi. In our next video, next part of the chapter, then, what we're going to look at is what's called a Monte Carlo simulation. And so we get to throw darts. It'll be fun.